Well, we're here on this cold morning with our new OSU Extension Soil and Water Conservation Specialist, Dr. Daniel Adamson. And Daniel, first, before you start jumping into what you have here, tell us a little bit about yourself.
Well, thanks, Curtis. I'm glad to be here. So I'm Daniel Adamson. I just joined Oklahoma State University this last September. I'm from Wyoming. I did my PhD there. I have a background in agronomy. I was a certified crop advisor in Wyoming and northern Colorado for about 4 years. I definitely have a love for soils and a love for extension, so I'm enjoying my new role.
So is extension what brought you here?
Extension is what brought me here. I grew up on a ranch, and there's always need for more and better information for producers, right? So that communication is really important to me. When I was an agronomist, there's just always a need for us to understand better what's going on in people's operations. So the chance to mesh that with an opportunity to do research to answer really important questions for people is what my aspirations were. So I'm happy to be here and have a chance to work on that.
Well, we're really glad to have you here, and I'm sure the producers are going to be glad to have you here in the state as well, because it's been a little bit since we've had this position, you know, active as an active role in extension.
Yeah. Something that I think is really great is what I have felt so far is that Oklahomans naturally have a really good sense for what soil conservation is, right? Because the state has experienced a lot of the ramifications in its history for not taking care of its soils. So I think people are really sensitive to that, and they want to take good care of their soils. So moving forward and understanding kind of what soil health is and what regenerative agriculture is and how those things mesh with practical management are some things I'd like to work on and focus on while I'm here.
Yeah, well, let's just dive right in. You actually have some samples here to kind of show just like some producers just to see what they actually have out in the field.
So number one thing about soil science, right, is what is your soil's texture? So remember, texture is the proportion of sand, silt, and clay particles that are in the soil. Yeah. So sand are the big ones, right? The ones that have the bigger grain sizes that we can really feel and that we sense. And clay is microscopic, but it really drives like how sticky the soil is, or its water holding capacity or nutrient holding capacity, right? So sometimes you say, oh, I have a silt loam, or I'm farming in a heavy clay, right? And you can do a formal test of that, but even simpler is you can just do it by feel, right? So there's a process that we can do by feel, so we can try that today. So I have some samples here, but you know, nice warm winter day like today.
Might as well get our hands even more cold.
Exactly, get your hands cold.
Let's do it.
You know, get out in the field, grab some soil, okay? Wet it up until it feels kind of like Play-Doh. So I've done that already. So this is a very clayey soil. Okay. And what you want to do after it feels like Play-Doh, it's nice and plastic and malleable, grab about a ping pong sized ball of that. Yeah. And just feel it. Okay. So step one in this process is does the soil actually hold together and form a ball? Yeah. So clay obviously does, right? So inherently we know that we can form clay, and it's very malleable, right? So you know, in the field, it makes, you know, farming in this difficult, obviously. Right. But it does hold a tremendous amount of water, and it does hold a lot of nutrients. So that's the benefits of having some clay in your soil. But what we want to do is we want to start squeezing it between our thumb and our forefinger and make it flat. It's called making a ribbon. Perfect. Now clay obviously is very strong, so it makes a very strong ribbon, and it holds itself together well. Yeah. So if a soil holds itself together more than 2 inches like this, that's the determination that it's a clay. Oh, okay. So excellent, right? Just feel like you're in kindergarten again. Making
exactly. I'm having a good time. I love
That's a true clay. Okay, let's take a step to the other end of the spectrum, right, is a true sand, right? So it's those big coarse particles. Right. So this is moist, but you'll notice it doesn't hold together at all, right? Yeah, not at all. Yep, so if it doesn't hold together at all, it's a sand, right? Okay. Obviously, sandy soils have problems on the other end of the spectrum. They have poor water holding capacity and poor nutrient holding capacity. So what does it mean, like everybody says, oh, I want a good silt loam or a loam, right? What does that mean? It means there's a nice, kind of an even mixture of the sand, silt, and clay particles. So it gives you better workability, right? But you don't sacrifice good water and nutrient holding capacity as well. So tell me what you feel in that one specifically compared to the clay that we looked at first. How does it compare? It's definitely breaking apart. Right, it's more like friable, right, and malleable. But it holds together still, right? So next is try to make that ribbon. Okay. You can already see it's just crumbling. And it doesn't really want to make a strong ribbon. So the determination of the loams are, the ribbon tends to break off in chunks less than 1 inch. So here's a nice example of one that's broken off in about a chunk that's less than an inch. So that tells you have a loamy soil.
Oh, okay.
Now you can have soils in the clay loam type area, so it's kind of a mixture of a loam and a clay. Those ones break off in inches, in bands between 1 and 2 inches. So it's moderate between that clay and that loam field, right? We have a lot of loams, clay loams in Oklahoma as well. So obviously good deep soils that hold a lot of water help us in our dryland ag. So if folks want to take a minute and just go out and see what they have, and
what time of year is great? You know, what time of year? Right now, you know, the ground's really hard. The soil's pretty hard. It's really
the soil's frozen. We don't want to do that. You know, can't get the process done. But for me, even as a soil scientist, I feel like I'm much too lazy about doing this. I should always do it more than I do, right?
Yeah, I think that's how everything is.
When you're just kicking around the field, if you got your water bottle or if it just rained, just grab some soil, pick it up, and feel it. And texture changes across the field, right? So you probably know, why does this part of my field always perform poorly? Do a little hand texturing. It might be sandier there, right?
Yeah.
And also note that the texture changes as you move down the soil profile with depth too. So there's a lot of power in digging a hole.
Yeah.
So it's good to have as much information as you can. And when in doubt, if you don't feel like you're strong at texturing and you're a little confused, there's a lot of good resources. The NRCS Soil Web Survey is an online resource you can look at.
In the local county extension office.
Exactly.
Yeah. All right, thanks, Daniel. Daniel Adamson, OSU Extension Soil Water Conservation Specialist here at Oklahoma State University.